This is called a VIR chart, and it shows you how voltage, current, and resistors behave in circuits. We can use the chart to figure out how much current runs through a given resistor, the voltage across that resistor, or the equivalent resistance or current for the entire circuit. The V is voltage, I is for current, and R is resistance. Ohm's law tells us that voltage is equal to current times resistance for a given row that represents the value for a given resistor. So if we know 2 out of 3 variables, we can find the third. Let's figure out a sample complex circuit. This is a general example. Let's find the current through and voltage across each resistor. We have our speakers, a video monitor, a video player, and a gaming system in this diagram. Let's fill in what we know. We can put all of our resistors' values in the right-hand column. We know that our power source is 110 volts, so we can fill that in for the total voltage of the circuit at the bottom of the second column. Often, our first step in solving complex circuits is to find overall circuit resistance and then overall current. We do this by adding circuit resistors together until we are left with a single equivalent resistance for the whole circuit. Remember that when you add resistors, you must be aware of whether you are adding in series or parallel, since different addition rules apply to each. As we go, we'll see updated circuit diagrams that reflect the resistors we've combined. There are lots of approaches we can take to solve these problems. Let's begin where resistors are in parallel in a circuit. 1 over our equivalent resistance for our resistors in parallel equals 1 over our first resistor in parallel, 2 ohms, plus 1 over our second resistor in parallel, 15 ohms, plus 1 over our third resistor in parallel, 12 ohms. When we add the 3 resistors in the video branches, we get an equivalent resistance of 1.5 ohms. Now all we need to do is add these 3 resistors together in series. That will give us our total equivalent resistance for this circuit. Since the resistors are in series, we add them using our series addition rule and find that the total resistance in this circuit is 9.5 ohms. Now here's our complex circuit, simplified to a single equivalent resistance. Now that we know the equivalent resistance of the circuit, we can put that value into our VIR chart. Since we know 2 out of the 3 variables, we can use Ohm's law to solve for the total current in the circuit. We can rearrange Ohm's law to solve for current. Current is equal to voltage divided by resistance. When we plug those values in, we find the total circuit current is 11.6 amps. Now let's go back to our VIR chart and fill in what we found, which is total current. We can choose among several options to fill in the rest of the blanks. We just choose one and go with it. Let's figure out the current in each of the 5 circuit resistors. We'll use the fact that in a parallel circuit, the total current equals the sum of all of the currents through the resistors, and in a series circuit, total current is the same for all of the resistors in a circuit. Right away, we know the current running through the 2 4-ohm resistors that are in series is 11.6 amps. So we put 11.6 amps as our current for those resistors in our chart. We now have 2 out of 3 variables, so we can find the voltage across each of those resistors. Using Ohm's law, we can find the voltage drop across each 4-ohm resistor. Voltage equals 11.6 amps times 4 ohms, so it comes out to 46.4 volts per 4-ohm resistor. Now, we'll put those values into our chart. Now, let's look at the relationship between the voltage in series and parallel circuits, which is similar to that of current, but it's flipped, like this. The total voltage in a series circuit equals the sum of all of the voltages through the resistors. In a parallel circuit, total voltage is the same for all resistors in parallel. Since each 4-ohm resistor has a voltage across them of 46.4 volts, this gives us a total voltage drop across those resistors in series of 92.8 volts. That means the total voltage drop over the entire parallel circuit branch is 110 volts, the total voltage of the circuit, minus 92.8 volts, the voltage drop across the two resistors in series, which gives us 17.2 volts. For the resistors in parallel, each one must use up the same voltage, 17.2 volts. We can now plug that value into our chart for the voltage across the 2 ohm, 15 ohm, and 12 ohm resistors. We now know 2 out of 3 variables in these rows, so we can solve for current again using Ohm's law. Let's rearrange the Ohm's law equation again. So current is equal to the voltage divided by resistance. And we find the current for our 2 ohm resistor is 17.2 volts divided by 2 ohms, which is 8.6 amps. For the 15 ohm resistor, it's 17.2 volts divided by 15 ohms, which is 1.2 amps. For the 12 ohm resistor, it's 17.2 volts divided by 12 ohms, or 1.4 amps.